So compare the rate of change and initial values. So I can see why we might have struggled with this one because I feel like the verbiage in the unit wasn't necessarily this. Rate of change, do you know what rate of change is referred to on a line? Say one more time. Slope. So when they say rate of change, that means slope. We're comparing the slopes of these different representations. And initial values is what on a line? The y-intercept specifically. So I know that seems weird because like this line goes to the left of the y-intercept as well, but technically like when we're relating it to the real world, they're always like an initial value of something, your y-intercept is. So we're comparing the slopes and y-intercepts when one is a table and one is a graph. The graph is probably what you're more familiar with. So for the graph, what is the slope? Can you just tell me? Okay. When you're finding slope on a graph, what formula do you usually use? Rise over run for slope. Y equals mx plus b is just slope intercept form. That's not helping me find the m, the slope. Better? So it is going to be 4/7. So to find your rise over run, you want to pick two parts of the graph you could see really clearly without having to estimate. They even picked them for you this time. But when I say like that, you don't have to estimate, like I wouldn't want to pick this one because I'd have to estimate it, right? So with that, maybe draw out a triangle or at least envision one, and you're counting how much you have to go up to get to that point. That would be the rise. 4. And your run would be how much you have to go to the right to get to that point. So it's always left to right, like how you read. So it's 1, 2, 3, 4, 5, 6, 7. Your run is always positive. Your rise, it can depend on if you're going up or down. So we went up, so it's positive. That's my rate of change for function 2. It doesn't actually look like they're making you say the initial values, which is good because I have to estimate that. It's not nicely on the point, but just know initial values. Now let's look at the rate of change for function 1. You could graph these if you wanted to. Like if you have no idea how else to do it, I did look at graphs in Desmos. The way to graph them, you could either type all the coordinates in, would probably be the easiest. So I had what, 0, 2 or 2, 0, 9, 4, 6, 18. Really, you only need 2. Oops, why am I writing it like that? All right, so really I could do it just from those 2 and count my rise over run. Notice that the way Desmos is oriented right now, the tick marks are kind of tricky. It's like going up by 0.5. So you might want to adjust to where they're going up or down by 1. So then if I'm doing it here, I'm counting my rise to go from here to here. I'm going up 1, 2, 3, 4. And my run is 1, 2, 3, 4, 5, 6, 7. So their slopes are the same. They're both 4/7. So you put that their rate of change is equal to each other. So that's probably the easiest. Really, when you have a table, there's this other one, but we didn't see it in the unit. So I'm kind of hesitant to like make you learn it now. But just like as a side note, whenever it's from a table, slope can also be written as the change in y divided by 2x. So like pick 2 areas to look at. Don't like switch it up. Say I pick these 2 parts to look at. What's my change in y? Going from 0 to 4. And what's my change in x going from 2 to 9? And if it was going down, make sure you put negative and things like that, but from a table, this formula is probably easier. But Desmos is more like what we saw in units, so. Questions on that one? Questions on others? From any subject, paper one. Yes, Austin. Question 6 on this one. It always lags too much in the mornings. But we have the school store sells pens for 75 cents each and pencils for 25 cents each. Anthony spent $6.25 and bought a total of 11 pens and pencils. It says, how many pens and pencils did you buy? So this is similar to what we were trying to focus on yesterday. In order to accurately solve this, you need to be able to create the system and solve it. So identify your two totals. Table 6, can you tell me the two totals in this one? Good, and can you tell me the other one? 11, good. So I tell you to identify your totals because that can help you make your system, right? Totals are alone on one side. So then you have to think what contributes, say, to like the total of 625. So table 1, can you tell me what should go to the left of it that contributes to the 625? Okay, great. So when you have dollar amounts, what is on the other side is usually a dollar amount. Sometimes the X and Y is the price. So like sometimes maybe we don't see these dollar amounts and we see how many they bought. But this time we're solving for how many they bought. So X is what in this situation, class? The number of pens bought, because that was the one that was 75 cents. And the Y is number of pencils bought. So also remember, systems should have the same variables in both. So like this one, I should have an X and Y in it because that's how I solve them, is I need to have the same variables in both. How can I represent the buying a total of 11 pens and pencils? What would I write? X plus Y. Simple as that. If X is number of pens bought and Y is number of pencils bought, all I really have to do is count them. I don't need to multiply them by anything. Maybe by 1 if you really want to get technical about it, but they need to add up to 11. So once you have your system, like for example, this one isn't making you show your work. What would probably be the easiest way to solve this one? Desmos. You could do elimination if you manipulate the bottom equation. You could do substitution. You could try graphing it, but the graphing with Desmos will probably be the best, most fast and accurate way. So that's what we're going to do. So that's 0.75x plus, I want to say 0.25, but I don't remember, plus 0.25y equals 6.25. If you picked different variables, I would just recommend do X and Y anytime you have the option. That way, when you read it, the coordinate where they intersect, it's easier to identify which is which. Also, Desmos doesn't read other letters, it just reads X. So here's my system we created. Here is where they intersect. What did we say X was? Pens or pencils? So the number of pens bought, so that's what you should enter for exactly 7. And then the 4 is the number of pencils bought. So that's why you have to define your variables. You need to define your variables on your constructed response test, so if you don't lose points. But then that way, when you read your graph, you know what number is which. Sometimes it asks for just one of them. So you have to give either the 7 or 4. You have to know which. Questions on that one? Okay, questions on others? So 7 pens, 4 pencils. Don't be shy, this is your time. If you don't ask before the test, and we'll just struggle with the same question. You could always email me too. I do record all my classes, so if maybe they ask different questions, you could go check that out, but don't ask even by email, like. Any others? Good question. Any from the paper study guide? We good on that one? Massimo?
Oh,
Okay. Okay, let me pull that one. So you're talking about the one that says optional. So keep in mind with the optional one, it's different practically every time you take it, but that one is really good at telling you like a good prediction of how you'll do. And you said 11. Let's see, because it's gonna be. One second. So a hotel has 150 rooms. The charges for a double room and single room are $270 per night and $150 per night, respectively. On a night when the hotel was completely occupied, revenues were this much. Which pair of equations can be used to determine the number of the double room and the number of the single rooms in the hotel? So we're making the system. Identify your 2 totals. So what's one of the totals? The 33,300. And what's the other one? 150. So let's see if that eliminates any. So I definitely don't want to pick this one, and it could be shuffled on yours. So don't pick the one that doesn't have the 150. So that narrows me down to 3 of them because the rest of them have these totals. Now think of what contributes to that total. So like for the 33,000, that's a dollar amount. That probably is paired with the other double amounts that are in the problem. So what do I need to write that makes the most sense to the left of the 33,300? And this one's multiple choice. So you even have some options. So like looking at A, the one that's equal to the 33,300 was the 270 for the double rooms. Okay, so that so far is looking good. Was the 150 for the single rooms. So that so far is looking good. B does not have that dollar amount associated with it. So I can automatically say B is not going to be it. D does have the same thing. So now I'm choosing between A and D, which do they not look exactly the same? Oh, wait, no. D, what's wrong with D? They switch the variables. The double rooms cost more than the single rooms. So that eliminates D as the option. So does that make sense for how to problem solve it? Okay, nice when it's multiple choice, but can't say it will always be for all the right equations. All right, questions on this one? Question on others, any part of any study? This one's the one that says optional and extra credit. Yeah, and I mean, it's great for practicing for the tests. But yeah, it is a lot of questions, I guess, and to get the most extra credit, you have to be accurate on them, but it is good practice. Like in college, we had this software for our homework, and they told us that if we did the practice test 20 times, because it was like different questions every time we took it, that if we did it 20 times, then we would for sure probably get an A, and it was true. I was up like all night doing it 20 times. But that was in college. So. All right, anyone else? Okay, yes.
Is it possible for me to go over the how the graph and it's like I know how to find the intercept. Okay, I don't know what the other ones are.
Okay, that's a good thing to review. So graphing by hand. I'll just write it on this one because this one involves you having a graph by hand. So if you guys want to do the same, you know, I'd recommend that. But in order to graph by hand, what form is the easiest to graph from? Slope intercept form. So you would make sure the equation is in what? Y equals mx plus b. Because when it's in that form, what is really easy to see? Well, the y and x will stay y and x. So your slope is easy to see, and you do need that for graphing. What else is easy to see? The y-intercept. So if it's not in slope-intercept form, which probably from part A, when you make that real-world situation, it's probably not in slope-intercept form. You want to rearrange it into slope-intercept form by isolating the y. Okay. We can practice on in a second, but put it into slope intercept form, and then what do you usually graph first? And that's usually your starting amount, so that makes sense. So you plot your y-intercept on your y-axis. Hopefully you know this one's your y-axis, y to the side. Your 0 on the y. Okay, so you plot your y-intercept, and then how do you know where your next points go? What's the other thing you can see in y equals mx plus b? The m. So in y equals mx plus b, m and b will be numbers. So that's what you use. M is for slope. I know it's weird.
Oh, okay, I'm sorry.
But yeah, m is for slope. So anyway, you plot your y-intercept, and then you use your slope, which is rise over run, to plot the next points. And I say points because, especially for systems, you probably need multiple in order to create a straight line. Like you don't know where they're going to end with that. But yeah. Do we want to practice that for a minute? Okay. What's the, and I'll scroll back down, so don't worry. But what's the equation for part A? What do you guys write for this situation? X plus 2 1 plus 1 equals 2. Okay, great. So X being hats, or like, yeah, the cost of the hats, and Y being the cost of the gloves. So I'm like making sure that makes sense. So good. I'll just rearrange one of them for you. So 4x plus 2y equals 20. Let's rearrange that into slope intercept form. If we want it to be in slope intercept form, what do we have to get alone? And what's farther from the y right now? the 4x, because think about how to make it cancel. It'd have to be 0 plus 2y, right? Because normally you don't write 0 plus something. So how do I make a 4x cancel? Good, we're gonna do that on both sides of the equal sign. So subtract it, whatever you do on one side of the equal sign. And that will get this to cancel. So right now it's 2y. And are these like terms? So I'm not going to combine them. It's not going to become 16x. What I will do is write it as negative 4x plus 20. So that it looks more like mx plus v, but you can leave it as 20 minus 4x. As long as you know what's the slope and what's the line. All right, but the y is not completely alone. So what's opposite of multiplying by 2? Whatever you go one side. And remember that warm up where, like, if I put the whole thing over 2, you're really simplifying both terms by 2. Okay, remember to do that for both terms. The numbers you can simplify was negative 4 divided by 2. Good, and the x will still be there, so I'm just simplifying the numbers, negative 2x. And then what's 20 divided by 2? Can you scroll over here for me? Yeah, thank you so much. So 20 divided by 2. So here's something in slope-intercept form that I can graph. So find 10 on your y-axis. Go all the way up at the top. And then use your slope to plot your next point. So remember, slope is always rise over run. Right now, it's negative 2. So if it's not showing my run, what is my run? 1. You still have a run. If it's not written, it's 1. And that means from my y-intercept, since my slope is negative, I'm going to go down 2 to the right 1. Down 2 to the right 1. The rise depends on if it's positive or negative, whether you go up or down. The run is always to the right. Occasionally, I do have to work backwards, like to the left of the y-axis, and that would be me doing the complete opposite of what the slope tells me to do. But I don't have to on this one. If you're not making a straight line, then something wrong. All right, I'll let you guys practice making, well, you already have the equation. So I'll let you guys practice putting that equation into slope-intercept form and then seeing where this intersects. I do, and I will after 4th hour, because that's my last algebra section. I will make the key for this part of the study guide visible today, and then you can see how you did, because you don't want to just practice it wrong, right? You want to check that you're right. But any other questions? Side note, while I have this one up, make sure you read the directions. Like, here's my system, that's great. But you also need to define your variables. So you need to tell me that X is the price of the hats. Don't just say X equals hats, because what about the hats? It's not number of hats. I already know that. I have 4 hats. I need to know what X is, and that's price of hats, and then tell me what Y is. Down here on part B, it says solve it by graphing. Label the graph of each equation. So that means for this one, it doesn't matter what form, but I need to see like what you graph. And then the solution. So where they intersect, make sure you tell me that's the solution. And then interpret it in context of the situation. So I don't remember what the solution is, but but say it's like 3, 4, then that means the hats cost $3, the gloves cost $4. I don't remember what. Okay, I don't know off the top of my head, but whatever it is, make sure you interpret it back to the real world. Okay. Yeah, go ahead. Yeah.